cube from yesterday. All right, so start making our cube from yesterday. Label all the vertices just like we did. A, B, C, D, E, F, and G. And I'm missing one, aren't I? One job. A, B, C, D, E, F, G. I'm missing H. There we go. Okay, how many play? Yes.
I think this one's for the parallel lines. The planes and stuff.
Say it again, Matt. What's that?
This like one is for the line. It says parallel
Yes.
lines, and then the planes is down.
Okay, I'm sorry. This is parallel line. I still want it for parallel lines. I misspoke. Yep, I misspoke. Okay, how many planes do I have up there? How many planes? Six. Okay, so let's talk about parallel lines. They need to be coplanar, which it means they have to be on the same plane as one of those six, right? So focus on one of those six for me right now. Just like you guys did yesterday, focus on one of those 6 planes. And what I want somebody to do right now is give me 2 lines on the plane you're focused on that do not intersect, because you are about to give me parallel lines. Okay, so focus on one of the 6 planes, give me 2 lines on one of those 6 planes that do not intersect. And you have yourself a pair of parallel lines. Boom, here we go. Let's start it off right here. We don't even have an 18 because I didn't adjust it from last class. Okay, let's try that again. There we go. How about Cameron? Got a pair of lines?
DC and BA.
DC and BA, you got it. All right, so DC. Have a little space in between that so we can write DC and BA. Those are definitely on the same plane and do not intersect. I do want to introduce the parallel symbol to you now. Mathematical symbol for parallel. Anybody know it before we go to show off there? What do you got, Cameron?
No, I said GC.
What'd you have?
G.
GC?
Yeah.
Yeah, that would happen. Yeah. I'm getting rattled today, guys. Rattled. GC and BA. There we go. Rattled. Anybody know the parallel symbol before I show it off?
Is that like just like 2 lines?
There, you're vertical. 2 vertical lines. There it is. We do not write the word parallel moving forward this year. We write the symbol for parallel. So if you want to make a little note for yourself, there's the symbol for parallel. 2 vertical lines. All right, 2 vertical lines. We are in honor, so how about another pair of parallel lines up here? How about another pair? Troom, get back in business. Sakura, what do you have?
CDGF.
CDGF, good. CD parallel to GF, looks good to me. Okay, everyone all right with parallel lines? You've probably seen them before, but maybe not as far as we're talking here on planes. And all right, ready? Next one here. Now we're going to go back to my triangular prism we've been working with yesterday. How many planes are on that one? 5, right? 3 rectangles and the 2 triangles. All right, can you find, I'm going to give you AC now. AC, what other line is parallel to AC? AC and, AC and, you want to find something that is not on the same plane here, coplanar. Ready? 10, what do we got, Sophia? What do you think? ACN? DF, good work.
Wait, why does the one AC not have arrows on it?
Because they're slacking. That's why it should have arrows. Relax over there. Okay, relax. Trying to call me out. DF. It should. It should, because you guys don't know what that is yet. That's why. You guys will figure out what that symbol means today. How about EF? EF and give me another line that is parallel to it. EF and go and Sakura, back to you. EF and BC, good work. And finally, someone AD. I'll actually accept 2 answers here. I'll accept two answers here. AD is parallel to actually two lines here. I only need one. Don't try to show off. Jacob got one pair. AD and
CF.
CF, yep. Or I would have also accepted, anybody got the other one here? BE. Good. All right, everyone good with parallel lines? Parallel lines got to be in the same plane. Do not intersect. All right, this next one I think is the toughest one we're going to do out of yesterday and today, and it is skew lines. Skew lines. First, how about this definition here? Lines that do not lie on the same plane. That's pretty easy for us, right? They can't be on the same plane. Here's the part that gets confusing. Those lines can't be parallel, and they can't intersect. What the heck is left, right? All right, we ready here? Riley, you ready? Need you to do me a favor. Hold up my cube that everyone has drawn on their paper. All right, hopefully the shoulders are good. I'm going to do a little workout here. All right, everybody good here? Everyone see my line I'm using there on that plane? Everybody's good there? Okay. Everyone see that one right there? Are they on the same plane? Okay, so that checks off box number one up there. Are they parallel?
No.
No, they are not. And can you see that they will never intersect each other, right? Because this is like three-dimensional space. I keep going out that way and I keep going this way. These two I have on the plane right now are skew lines. These are skew lines. Everyone good? Not on the same plane. They're not parallel, and then in three-dimensional space here, they'll never intersect. We good? How much more can I keep talking? So he's got to hold up his arm. Huh? Can I keep going? We good? All right, you're good. Thank you. All right, so let's use that definition now. Let's go back to my triangular prism. Let's focus on AC right now. What other part up here would be skew now? Skew to AC. So first thing is, right? Hey, look up here, take a peek. You cannot give me anything on plane ABC because they cannot be coplanar. And you cannot give me anything on plane ACFD. Because right off the bat, they can't be on the same plane. So anything from those two planes are not options. So what else are you going to tell me up here could be skew to AC? And we'll take a peek. All right, Riley, over to you.
EF.
Okay, EF, ready. Let's take a look at EF here before I write it down. Are they on the same plane? No. Are they parallel? No. And here's the part I got to get through to you guys. They won't intersect in three-dimensional. On your paper, they will, right? Because that's two-dimensional right there. But three-dimensional, it's going to go here and go up there, and they'll never intersect. Make sense? All right. I know people are like, oh, they do intersect. Watch. Well, you're drawing it on two-dimensional paper here. Okay? And that's not going to work. So EF is good for me. Are there other options? If I called on somebody else, was somebody else going to give me another option? Because I have something else written down on my notes here. What were you going to tell me there, Natalie?
DE.
I have DE too. Yeah, DE works. Okay, everyone good? All right, how about EF now? Let's turn our attention to EF. What could be skew to EF? Remember, don't give me anything on that triangular plane. And on BEFC, that's not going to work. EF and, I'll highlight it when you let me know there. What do you got, Gianna? EF and AD. All right. What do we think?
Oh, wait, I said AB.
Oh, I'm
I
sorry.
think that works too. Oh my gosh.
AB?
Yeah.
They are not parallel. They are not on the same plane, and they would not intersect each other, so that would be fine with me. Yep, AB. I gave away the other one, but I gave away AD as well. AD would work, yep. And then I'll go through, I'm not even going to draw this one. AD, skew to AD. You want to take it there, Fiona?
Wouldn't D be on the same plane as E and F?
AB and EF,
No, AD. Wouldn't D be on the same plane as E and F?
but they don't make up one of those 5 planes, though.
Okay.
See what I mean? AD and AD has this one right here, right?
Mhm.
and that one right there. All right, it's not part of that plane in the
Okay.
back, the EF. That's good. Okay, how about AD? AD, Sully, what's up?
BC.
AD and BC, that works for me. One's behind, one's going in front. I thought you guys were just going to go back to this one and go EF because we used AD as that answer before, right? EF also works. All right, any questions with skew? We're all good? Okay, skew lines, parallel lines. Perfect. All right, planes can be parallel as well. Planes can be parallel, right? Planes that don't intersect. And on this diagram, I made it nice and easy for you guys. There's only two planes that are parallel. There's no other planes that are parallel. There's only two of them. All right, so plane, name them for me. Name the two planes that are parallel in that diagram. Security, you're on fire today. What do you got? Plane. Remember, they can't intersect each other.
Plane B, A, C.
Yep, good job. I love that you named it with 3. Remember that from yesterday. Let's use our parallel symbol with, sorry to cut you off.
Plane D, E, F.
There you go. Only two planes in that diagram that are parallel. Everything else intersects. Good. And ready, here's a little honors one right here. How can a line in a plane be parallel? I get two lines parallel. I got two planes parallel, but how can a line in a plane be parallel? Here's how. You just got to help me out here. Michael, you ready?
Oh, yeah.
Name one of the parallel planes we just found out.
ABC.
Okay, ready? So plane ABC, let me show you guys now how you can determine what line is parallel to it. Ready, Michael? Back to you. What other plane was parallel to ABC? Pick a line from it. Okay.
ED.
It's parallel to the other plane then. You said what, ED?
Yeah.
Yep. And here's how this works. If two planes, ready? If two planes are parallel, one plane is parallel to any line in the other one. Okay, let me say that a little slower. If two planes are parallel, which we have in number 7, one plane is parallel to any line in the other plane. Make sense? Makes sense? I can't hold this for long, so it better make sense. We good? Okay. So there we go. All right, can we be done talking about planes now? Because I want to get more excited with what we're about to do, which is connecting algebra with geometry. Ooh, that scares some of you based on last year, huh? Scares some of you. All right, here we go. Yesterday, I introduced you guys to a line, and I got so fired up. I said, darn it, when you draw a line, what's got to be at the end of them? Arrows. Because I said if you don't have the arrows on, it's called something else. There it is. A line segment. It is a part of a line. All right, so pretend you have a line, drop the arrows, you now have a line segment. But the ends of them are called endpoints. So X, I'm going to put X and Y here. That is a line segment. It is part of a line. All good? Remember how to write a line? You put the little arrow with the letters underneath, the points underneath. Same thing here. How do I represent this line segment XY? Line segment, and then you put the two endpoints underneath. Does the order matter? No, it does not. Order does not matter. Just got to be the endpoints. So that's how you represent X line segment XY. Yes?
Can you put endpoints on that to make you remember or no?
Yeah, that's fine. I'm okay with that. Yep, if you want to put endpoints. The one thing I'm only concerned about is, don't do this. Let's say I put a random C there. You cannot call this line segment XC. That's a different line segment. See what I mean? You have to call this, if you want the full one, it's called XY. If you start giving me XC, that's a different line segment. Okay, kids? All right, now let's have a little fun here. Draw EG. Go ahead. I'm going to walk around, draw, and then look what's above it. Line segment. So draw line segment EG for me. Do your own line segment called EG. Here we go. EG. Point F is somewhere on the segment. Do I say where? No. So put point F on there. Doesn't say where to put it, so just put a point F somewhere on that segment right now. So we all have a nice little beautiful diagram here. All right, now look what happened. And this is not a typo. If EG, look how I wrote EG up there. What's missing? The line segment symbol above, right guys? The line segment symbol is missing. Why is it missing? Because if it's missing, it is now telling you what the length of it is. All right, so if you do not see the symbol anymore, they are telling you how long that sucker is. So EG has a length of 100. 100 what? Who knows? Doesn't matter. So EG is 100 units long. All right, so if you do not see the symbol above, it's telling you the length now. All right, EF. Everyone see I dropped the symbol, right? So the length of EF is 4x minus 20. And I dropped the line segment symbol on FG. That's 2x plus 30. We have 3 jobs right now. Find x, and then, what's this mean again? EF with no line segment? Find the length, the actual number. The answer to this is not 4x minus 20. I want, because the line segment was dropped, how long is it in an actual number, not variables. All right, so it looks like we need your help with an equation to set up with an equal sign so I can solve it for x. Are we told that EF and FG are the same length? No, so I don't want to just set those equal. I want to involve the 100 as well because they wouldn't have given it to us otherwise. I know EF, I know the length of FG, and I know the length of the total segment. Again, I'm trying to set up something to solve for x. All right, let's turn it over to you guys. Got something for me to set up there. Maddie, what do you think?
You could do 100 equals 4x minus 20 plus 2x minus, or plus 30.
There you go. The 2 segments put together, added together, give me 100. Good job. And unfortunately, because you are in what class? Guys, I don't have time to review how to solve that. That's got to be, at this point right now in your math careers, you should be rolling right now. Use your calculator for anything. I do not discourage you from using your calculator on simple math. Maybe you've had teachers in the past that grilled you for using it for simple math. That's what they're there for. Use it. When you have the value of x, let me know. Take your time, though. Take your time. When you have it, let me know. Fiona, when you have it, let me know.
15.
15. Good. There's one job down. X equals 15. Next job, find the length of EF. And that's got to be an actual number, not 4x minus 20. Talk to me. How can I find, now that I know x, how can I find the length of EF? Talk to me. Isabella?
You substitute x with 15.
Perfect. Substitution. 4 times 15 minus 20. When you have that, Isabella, let me know. 40. Good. Job number 2 down. One more job to go, and that is to find the length of FG. A couple ways you could do it. You could do Isabella's substitution method, or how do we already know how long is the whole segment.
So you just minus 40 from 100.
It's 100, right? So one part's 40. Sully, go ahead. What's the other part then?
60.
60. That's what I love. The geometry and the algebra coming together. Any questions about that? I know it's real tempting to set 4x minus 20 equal to 2x plus 30, but we do not know they're the same length, so we don't assume it. Questions? Yes, Fiona.
When you start the problem, you obviously don't know like which is which.
Yeah.
Does it matter where you put F? Okay.
No, I don't look at diagrams.
Okay.
I look at the work you put in. Yes, not drawing the scale. That's what I always say. Not drawing the scale. Questions? Yes.
For showing the work of FG, would you actually just put 60, or like do you have to show more work of like 100?
That's fine.
Okay.
I don't need to see. You know, by the time you get to this point, I kind of know that, you know, it's 60. Here, though, like if I just see a 15 pop out, I'm going to be like, that's a little shady. Where'd you get the 15 from? Good. Anybody else? All right, one more vocab term.
Book.
Book. Good job, Sally. Good. You're on top of it. Because people just go right down in, they don't even see it, and the person could pop up, and I go nuts, and you don't understand why. Congruent segments. Segments that have the same length, but here's the catch. I don't know what the length is. Okay, I don't know what the length is, but I know they're the same length. Okay, that's congruent, right? Same length, but I just don't know what the actual length is. Can you guys do me a segment XY again on that for the picture? Draw me segment XY. And right underneath it, can you do segment AB that looks the same length as XY? So give me XY again. And then right underneath it, give me AB, which looks like the same length as XY. All right, first thing, how are we going to know that they're actually the same length if I don't put any numbers on them, right? One answer, and this will never, ever be an answer in here, so let me just warn everybody now, September 9th through June whatever, because it looks like it. That is never a response I want to hear unless you would like me to come over and put you in a headlock, okay? Because it looks like it will never be a response. Okay, Mr. Carlino, I get it, so I will never say that. But how do you know X, Y, and AB are actually the same length? You will see markings on them. Specific markings that say, hey, these two are the same length. And here are the markings. They are called what I call hash marks. So you will see this on those segments. That tells you they're the same length, which makes them congruent. Okay? Notice, did I put any numbers on them? Like 6 inches? No, I don't need to. As long as I have those hash marks, you know they're the same length. All right, now how do I write that they're congruent? Remember, there's a parallel symbol? Well, there's also a congruent symbol. All right, so let's write this right now. XY, give me a little space, AB. And now I'm going to put something in between them that says they're congruent. Anybody know that symbol? This is maybe a brand new one for you.
Is it like the squiggly?
Oh my God, that might be the least mathematical thing I've ever heard. The squiggly?
The like
The squiggly.
sign.
You have 1/3 of it correct.
Oh, cool.
There's 2 other parts to it, which is
Is it a U?
a U. Like what are we, union? Intersection? Is that what you're thinking?
Like
I know what a U is. Thanks for drawing it. I know what it is. Thanks for the alphabet. No, Julie, I'm sorry. No, I think you're thinking union. The squiggly part is part of it. That's what I'm saying. The squiggly is part of it, but there's 2 more parts to it. Fiona?
Isn't it like an equal sign with that on top of it?
Yes, there it is. Equal sign with, and can we stop saying squiggly? Does anybody know the official name for that bad boy? No, really. Equal sign with the final time I say this, the squiggly, yes. Anybody know the official name? You can impress people later. Tilde. It's called the tilde. Yes, a tilde. So just make a note. That is your symbol for congruent. Squiggly. What class are we in?
Honors.
Okay, I have an honors level question for you now. And I'd like you to do the same on your diagram. Let's say we took segment XY and extended it out to point C. And let's say we took segment AB and extended it out to point D. What markings, what would I put on YC and BD if they're congruent to each other, but not congruent to the other 2? So I can't put 1, 1, 1, 1 because they're all 4 aren't equal. I want to show just those 2 are equal, but not congruent to the other 2. So what do you think I do instead? What do you think, Sully?
All like the two.
2 hash marks now. Okay, you just don't have 1. Now we would have 2. Okay, so that shows YC congruent to BD, and that shows AB congruent to YXW, or XY, excuse me. Okay, so you might see multiple hash marks. All right, final example, and then you guys can get going with the assignment for tonight. Which one of these statements below? Incorrect, incorrect. All right, look at the diagram I gave you. Look at that diagram. Everyone see the hash marks? What are they telling you? This is where I need you to be. What are those hash marks telling me on the diagram? What are congruent? Name them. Use your big words here.
A, B, and C, D.
A, B, and C, D are congruent. Everyone agrees. So that means choice number 1 is true, yes? Okay, we're looking for the incorrect one. All right, keep going. What do you know about congruent? If they're congruent, they have the same what? Length. And isn't that what number 2 is telling you? Because what's missing? The top part, right? The segment part. And if the segment part is missing, it's saying the length. So is everyone all right? Well, we already know 1 and 2 are true because of those hash marks. So those aren't our answers. All right, now we go to these 2. Is AC, everyone see line segment AC? Is that congruent, the same length as line segment BD? What do we think here? Let's see, make sure we got, here's AC, and here's BD. Do we think they're the same? And we can't just say because it looks like it. We got to say something mathematically to say yes or no. Whew. Look at AC. Everyone see AC? AB is a part of it. What do you need to add on to AB to get to AC? So here's AB. What do I need to attach or add on to it to get the full line segment AC? What do I need to attach onto it?
BC.
Everyone agree it's BC? Yes? Okay. Let's go over here to line segment BD. So let me just, and you guys don't have to write this. I'm just writing out what we talked about. So it's AB plus BC. Agreed? All right. Go to BD for me. How do I form BD? How do I form BD? I got to take CD and add what to it as well? What do I have to add to CD? BC, right? What do I already know about AB and CD? They're congruent. And what am I adding to both? The same thing. So aren't the totals going to remain congruent as well? Make sense? So that's true. The one that's not true? AC congruent to CD. Everyone see why? All right, not because it looks like it, but I guess you could use that pretty easily. But AC, how's AC made up again of? AB plus BC, and CD is equal to BC. And I'm adding more onto it, so they can't be the same length. Okay? All right, tonight, I get a little nervous about tonight. Part of the homework's out of what?
On the packet.
In the packet. And the other part is on Google Classroom. So be careful there, kids. All right, keep it all straight tonight, please. Keep it all straight. You can start that homework now.